Greetings. Remember I told you some of these problems were related to each other? Let's take a look. Let's begin with ax plus x squared equals b squared. And let's think about this problem. What we're saying is, given some distance a, onto that we're going to add a distance known as x, and from that I can create a square and a rectangle that when added together would be equal to b squared. So this overall length right here could be given by a plus x. But let's see if we can flip that around for a minute. Instead of saying this overall length is a plus x, let's say this overall length is actually u. And what I want to do now is write down a new equation in terms of u as an unknown. So u is equal to a plus x. Well, solving for x, x is equal to u take away a. Now let's see what that's going to do for us. I'm going to plug this into my equation, and I'm going to have a times x, but x is u minus a, plus x squared, so that's u minus a as a quantity squared, and that should be equal to b squared. Well, let's see what happens now. So a times u is au minus a squared plus u squared minus 2au plus a squared equals b squared. Well, let's simplify our life now. And we know that a minus a squared and a plus a squared will add to 0. And if I have negative 2au's and a positive au, that's going to be minus 1au. So I'm going to have u squared minus au equals b squared. Now u is your unknown. If it doesn't look familiar to you, I'm going to really beat up mathematical notation, but I'm going to replace the u's with an x now and have x squared minus ax equals b squared. And notice that's not what we started with. What it's showing is what's called a change of variable in a problem. This equation and this equation are basically have some form of equivalency through a change of variable. That's all we're demonstrating here. And if you think about it, that made perfect sense because the proof from geometry for both of these looked very much the same because of what we were doing. We either let the whole thing be our u squared and we ripped off a rectangle, or we had a and then we had to stick a little piece on it. But the construction was very similar. Because the construction is basically not just similar but identical, I can therefore talk about how these are two equivalent forms. Because sometimes I may not want to solve this equation, but I would rather solve the equation if it looked this way. All I have to do is change the variable, solve the equation, and change back to the original values. You did this in calculus. Tickety-boo. I hope this helps.